Hello, good morning to you all.
Good morning, sir.
Yeah, very good morning.
Good morning, sir.
Good morning. Yeah, good morning. Are you able to see the slides? Hello.
No, sir.
You are not able to see the slides? Sorry, my Microsoft Teams is giving immense trouble. I don't know why, but often it gives a lot of trouble. It won't start so easily. Will you now? Can anybody could confirm? Are you able to see the slides?
Yes, sir. Yes, sir.
Okay. Okay. So the one of the last topics of the pile foundation, so that we were discussing since post mid semester examination. Today, let us try to understand about the pile load test, because so far what we have discussed is how to determine the pile load capacity of an individual pile of a pile group, but basically by analytical equations which have been derived based on some assumptions. So say whether it is a shallow foundation or a deep foundation, it is mandatory to perform one field test to for the several purposes, which includes one of the primary purposes to confirm the pile load or the footing load that has been calculated by the analytical equations. So the objectives of any field load test is given here. So first of all, to obtain the back-figured soil data that will enable other piles to be designed. Now, if you recall, when we have calculated the pile load, we did use different friction factors and different soil parameters, which includes cohesion, angle of internal friction, adhesion, and effective stress, so on and so forth. Now, how do you confirm or ascertain that the soil data which has been used for the pile capacity calculation is right or not? So therefore, one of the primary or core objective of any field load test, here in it is pile load test, is to confirm that the soil data which is obtained by borehole, by making a borehole, is correct, and the same data can be used for design of other pile foundations or a group of pile. And another important objective is to confirm pile length and hence contract cost before the client is committed to overall job cost. Now here actually this is one of the most important aspect that as a civil engineer you must understand. Designing is one aspect, but cost is the another aspect. So though you may be very good designer, but if the client says that no, I don't want this kind of a design, then you don't have to, you do not have any other option except compromising on the design. Now, when you talk about the pile, the whole of the pile cost is associated with the pile length. Now, you may understand when you construct a shallow foundation, we hardly need to excavate 3 to 4 meter depth. But when you go for the pile foundation, you have to use heavy equipment which are very cost intensive, and the more is the depth you go, the more is the cost that increases. So therefore each and every meter counts when you go for the pile foundation, and especially if it is a going even behind 10 meters or 15 meters or 20 meters, or just imagine when you are constructing a Burj Khalifa, etc., then how much should be the depth of the pile foundation? It is 50 meter, 70 meter, 100 meter. So in that situation, just imagine if you want to go from 100 to 101 meter, how much is the cost escalation? However, to curtail or to say to a contractor that yes, this is the exact pile length that I want. So you must conduct one pile load test or many pile load tests. It's not a one. So there are several guidelines available. You can refer to Bureau of Indian Standards or ASTM codes or European codes. So almost every country has their own guidelines which are specifying or prescribing. So suppose how many number of piles should be tested from a bunch. Say for example, out of the 50 number of piles which are constructing, then one pile must be constructed, one pile must be tested for the pile load capacity, or so on and so forth. Again, there are variety of tests also, like routine testing or only single test. So maybe for the entire site, you may test a single pile, or suppose if there are hundreds of piles that are to be constructed, then intermittently, say for example for installation after every 50 piles or 100 piles, one has to verify or perform the pile load test. That is called as a routine test. A single pile load test or a routine pile test. Another core objective of either single pile test or routine pile test is to confirm the pile length, because it directly implicates the cost of the overall project. And to counter check results from the geotechnical and pile driving formula. Now the another way of calculating the pile capacity is pile driving formula, so that I will discuss after I discuss about the pile load test. And another important thing is to establish load settlement curve. Now, when you design any foundation system, shallow foundation or deep foundation, and elaborately we also did discuss during the shallow foundation that, so all Bureau of Codes, they prescribe two criterion for foundation design. One is stress failure or strength failure. The second is settlement. Now, the later one governs the former one. That means the settlement is more important. So this is one of the primary reasons. Though we have calculated the ultimate capacity of a foundation system, but we curtailed it to allowable pile load capacity or footing load capacity. Now, when we say the allowable, this is strictly keeps in mind the allowable settlement, so that no excess load goes onto the soil or on the pile material, so that they will not undergo the failure. That means a soil may fail prior to pile foundation or concrete, and vice versa. So whatever the thing it is. So therefore, another primary objective of pile load test is to establish load versus settlement. Then to verify the structural soundness of the pile. Uh, so here the structural soundness means, so suppose this is a pile which you are constructing below the ground. Now if it is a driven pile, then to some extent the control is in our hand, because the pile is cast on the ground, and with the help of the heavy cranes or rammers, we drive the pile into the soil sample. But what if you are dealing with in bored in situ cast, where a boring is made first, then from the bottom of the borehole you are casting the pile. So in that case, we do not literally know what is happening to the pile casting at the bottom. So certain percentage of the failures in pile foundation occur only because of this poor structural soundness of the pile. So therefore, pile casting is also one of the important aspects in pile foundation. So if you Google it, the poor structural soundness, you will get enough case studies where you can see how bad the performance of concreting. Uh, there are some challenges also. Just try to imagine if you are asked to construct a pile having a length of 30 meters, then how do you pour the concrete first of all from the ground surface to a depth of 30 meters? This is a big challenge. As a geotechnical, as a civil engineer, you need to understand. Okay, because nothing is visible at the bottom. We do not know what is happening also. We do not know whether we are covering the reinforcement or we are not covering the reinforcement. And if it is water inside, then how to lay the concrete again. So there are several challenges in the pile foundation. Okay, so if you get a time, so try to listen to some videos how to cast a pile of 30-meter length or 40-meter length, or how to pour a concrete or how to transport a concrete to a greater depth. So one of the simple thing that they adapt for transporting the concrete is there is something called as a trimmy pipe. So this is like your funnel. So they will take a one large funnel. So the mouth of the funnel is on the ground surface, but the tip of the funnel will be at the required depth, say 30 meter or 40 meter. So from the mouth, they will feed the concrete, and through this narrow tube, so it goes to the tip of the trimmy, tip of the funnel, and there it places the concrete. Now you may ask a question, sir, can we not directly pour the concrete from the ground surface to the bottom? The answer is strictly no, because you just imagine when you pour the concrete from the top to the bottom, anything can happen. One of the fundamental things that happens is segregation of the concrete. So we should never ever allow the segregation of the concrete. So therefore we must use some kind of a device by which we can able to transport concrete safely without losing its properties from the ground surface to the bottom of the pile. And unreliability of the prediction methods. So prediction methods means all analytical equations or driving formula or any other equation that you are using for pile load capacity. So this is the arrangement for pile load test. You can see. So this is the arrangement that was used for testing the pile load in Burj Khalifa. So this is in Dubai. You can see, hoping they have tested the pile for 6,000 tons. Very, very exhaustive amount of the load. 6,000 tons. That's why it was built for more than 100 floors. 6,000 tons. And these also different pile foundation, but for very large structure, you can say skyscraper. So this is another close diagram of the pile foundation. So here you can see there is at the top a static load is mounted here in this case also. So the middle is the pile and there is a hydraulic jack. I will show all the schematic diagram of the pile load. So this is a jack and this is some static load. This is also called as a Kentledge bridge. If you refer to any of the soil mechanics book or foundation engineering book, they will write this typical pile load test as a Kentledge bridge. So Kentledge is a person who proposed or developed this kind of a method of pile test. So now here you can see the cross section. This is called as hydraulic jack. So this is all jack and this is the pile material, and a lot of sensors are embedded all surrounding the pile as well as the jack. This is the pile and this is jack. So all these sensor systems. So these sensor systems help you to monitor the settlements, because that is what is one of the primary aim. As you progress the application of the compressive load, how the pile is undergoing the settlement depending upon the soil type. So the pile load test is done in every kind of the soil wherever you are prescribing the pile type of the foundation. And this is the typical sandbag pile load test and concrete pile load test. So these are the typical systems normally we use in India, while in usually European or American countries they use this automated jack and every system or any other system. So this is dead weight maintained by the sandbags or dead weight on top of the pile foundation, so by the concrete blocks. Now if you recall the very initial the discussion about the pile foundation, a pile foundation can be for different purposes. I may design the pile foundation for the axial pile where the compressive load is applied on the pile. So for example, if you look at left top figure, so this is how the pile load test is done of a pile subjected to the axial load. Now the another kind of the pile load test, that is pull out pile load test. Pull out means we literally pull out the pile from the ground. Now how to distinguish between these two? Suppose if you look at the axial pile load test, an immense amount of the surcharge load or the dead load is kept on top of the pile. Kept on top of this. For example, here you can see there is a surcharge platform which is mounted on concrete blocks. These concrete blocks are resting on the ground. Now, on this surcharge platform, another huge amount of the surcharge load, the for detailed understanding, the total weight of the surcharge load is almost twice that of the pile capacity. Suppose if the pile capacity is 100 kilopascals or say 1000 tons, the surcharge could able to bear up to 2000 tons. So that's what is the amount of the surcharge load. Now here, how do they do the pile test is, so this is the pile, this gray color is the pile material, and this small portion is called as a hydraulic jack. So they insert an hydraulic jack between the surcharge platform and the pile tip. And this hydraulic jack, typically you have already used for your concrete laboratory or soil laboratory, wherever you have done the compressive strength test. So this hydraulic jack, by the action of the hydraulic or what do you call, servo control or pneumatic, whatever, depending upon. So pneumatic means they use the air as a compressing fluid agent. In case of the hydraulic, they use oil as a compressing fluid agent that compresses literally to apply the compressive load, but inside some box. So they use the hydraulic jack. This hydraulic jack pushes the pile into the ground against the surcharge load. Now, how it pushes? That very simple reason. See, the intensity of the surcharge load is double that of the pile load capacity. So therefore, when I apply the load on the jack or with the help of the jack, since the surcharge load is almost double of the pile, whichever is the less load, that element undergoes the settlement. So here the pile is less capable as compared with the surcharge load. So therefore, the surcharge acts as a counter reaction mechanism against which the pile is pushed into the ground. Now, in case of the axial pile load, the surcharge exists, but in case of the pull out, there is no surcharge. You can see, rather we use another device that literally pulls out the pile from the ground. So it extracts the pile from the ground. So it is completely opposite. The pull out pile load test is an opposite to the axial pile load test. Now alternatively, the third test that is implemented on the pile is the lateral pile load test. So here if you look at the top picture, so this is the one pile and this is the another pile. So one pile is meant for the testing purpose and another pile is meant for the stationary purpose. Now one pile act as a counter reaction, the another pile undergoes the lateral deformation. For example, here you can see this pile is undergoing the lateral deformation. Here you can see there is a crack formation because of the lateral push against this pile. And here you can see how the pile is connected to the counter reaction using some hydraulic jack. So this is also hydraulic jack. So this is a picture of an hydraulic jack. So the same hydraulic jack can be used for the axial pile load or the lateral pile load, doesn't matter, because its function is remains same. So now the way it is connected, that depends upon. Suppose if you put on top of the pile, so then you are performing the axial pile load. But if you put on in the side direction, but at the top of the pile, then it is meant for the lateral pile load capacity. In case of the lateral pile load, no axial pile load is applied strictly. A lateral means only the lateral load, no axial load on the pile. And regarding the test also, there are two variety of tests that are normally conducted on the pile. One is static pile load test, next is dynamic pile load test. So in case of the static pile load test, all the three variety of the piles that I have discussed, the axial, the pull out and the lateral. So all three fall under the category of the static pile load test. Here you can see, so how they are conducting the static pile load test. Now on top of the static pile load test, it is also necessary in not every situation, but in depending upon your necessity, we also conduct dynamic pile load test. So here you can see from this picture, in case of the dynamic pile load test, a certain weight is lifted and dropped on top of the pile. So you can see the schematic as well as the realistic picture of the dynamic pile load test. Now, as a result of this impact, what would be the behavior within the pile? So accordingly, they insert a lot of different sensor systems, as you can see from the bottom right side picture. There is a theodolite target. So this will be useful to monitor how much is the settlement because of the dynamic pile impact. Then there are strain gauges. So these strain gauges are useful to measure the displacement. So there is a displacement. So both will give the displacement only, but one is in terms of the level monitoring and another is direct monitoring. So these strain gauges, they can also give you another kind of information, that is, suppose if there is too excess load on the pile, so the pile itself can undergo the deformation. So these strain gauges will give you not only the overall settlement of the pile, but the pile itself when undergoing the settlement, that information also can be obtained by the strain gauges. So these are the two variety of the test on three types of the pile. One is the pile subjected to the axial pile load, lateral pile load, and pull-out capacity. And on each pile, you may go for static pile load test or dynamic pile load test, depending upon your necessity arises in the field. So then what are the different precautions, or how do you conduct the test first of all? So I explained the mechanism. So this is the pile, and this is the counter reaction beam. On top of there is a surcharge load. Then there is a hydraulic jack which helps to push the pile into the ground. As the pile is pushed into the ground, so we need to monitor the settlement. So therefore we attach dial gauges, maybe 3 number or 4 number, and we take average of all the 4 or 3 as a average settlement. Okay, so with the help of the jack, we are applying the load, and with the help of the dial gauges, we are measuring the settlement. So therefore, we are getting load versus settlement graph. Load versus settlement graph for the pile foundation. Now, how do you, or how much amount of the load that shall be applied? So here the guideline says that the rate of penetration shall be 0.25 to 2.5 millimeter per minute. So in between you can choose any amount of the rate of penetration. So that is up to you. And these are some guidelines. The load is applied to the pile by a hydraulic jack. So this is the hydraulic jack. Increment of load for each step will vary depending upon the local building codes. That means US standards are there, Indian standards are there, European standards are there, China standards are there, Japan standards are there. So each country will give you a certain prescription based on which you have to apply the load. Now, how long will it take for conducting a single pile test? Can I apply the whole load at a time, or shall it be in incremental mode? So when you do any pile load test, the load is applied in increments. Maybe in 4 increments or 5 increments or 10 increments, so on and so forth. So the guideline says that the load increment shall be 1/4 of the working load. 1/4 of the working load. Suppose if your working load is 1000 ton, then during the step 1 you apply 250 ton. Then keep on monitoring the settlement. Keep on monitoring the settlement. So this single step of the load shall be continued until you see that there are no 3 consecutive readings of the dial gauges giving a change in the deformation. That means the entire deformation for an applied first increment of the load shall be same, or shall become constant. Once the settlement becomes a constant, then go for the next increment of load. Now that second step load is maintained until such time where the settlements are becoming the homogeneous or the constant. But this may be achieved, the constant deformation may be achieved in couple of hours or in couple of days. We do not know. That depends upon the soil type. So therefore, we literally do not have any kind of idea how long a particular load shall be maintained. But the guideline says that it should be maintained until 3 consecutive deformation readings are becoming constant, and test should be terminated at total load of 2 times the working load. So the final step of increment load shall be 2 times that of the working load, and pile is gradually unloaded after desired load is achieved. That means if you wish to carry out both loading and unloading, so you do unloading also after the loading is completed and measure the deformation. And this is how the full cross section of the pile looks like when it is embedded in the ground. Now when you do the pile load test, a certain element that is called as a O cell. O cell must always be put at the pile tip. So without placing the O cell, no pile test is conducted. Or if you are not using the O cell, an alternate mechanism is made at the bottom of the pile tip. Without making any alternative mechanism or without using the O cell, no pile test is conducted. So you have to remember. And since you are applying the load, so it is obvious depending upon your soil type. So the load transfer might be of skin friction or might be of the end bearing. So both you will get it. So skin friction as well as the end bearing. And here you can see on the ground surface there are different data logging arrangements by which we data log, and certain sensors are directly connected to the OCell. The primary purpose of using OCell is to embed certain type of the sensors, which also give some kind of the load or the settlement behavior of the pile that is being tested. So this is how the pile load test is done. Now what ultimately you are getting? So we are getting the load versus settlement. So here you can see O cell upward moment, O cell downward moment. So O cell downward moment means when you apply the axial load which pushes the pile into the ground. Now when once the all loading is done, that means once you have accomplished the final total load, that is 2 times that of the working load, then what you do, you slowly release the load now. So this releasing also will be done in an incremental mode. So when you release the load, then O cell rebounds. That is called as the O cell upward moment. So suppose if you look at this graph, load versus moment, from the axis, if it is below, that indicates that the pile undergoing the compression. The above indicates that the pile is rebounding. But the rebound can also be understood in a different way. So it can be also understood as, suppose if you do the reverse test, that is pile pull out test, then what you get is only the O cell upward movement, not O cell the downward movement. So therefore don't get confused. The upward movement corresponding to 2 things, either rebound or pull out capacity, but it is preferably rebound only. Now you can see the response of the pile also. So as you increase the load, there is an increment in the deformation, that is movement of the O cell in the downward direction. So depending upon the type of the O cell, the type of the curve, you can interpret. So what could be either it is end bearing capacity or the skin friction, whatever it is. Now the another benefit of inserting the O cell is that when it is rebounded, that rebound can be taken as somewhat like a skin friction value. So the O cell downward movement is interpreted as the end bearing capacity, while the rebound is interpreted as the skin friction. I repeat again, when you use the O cell or when you monitor the movement of the O cell, the downward movement of the O cell is interpreted as the end bearing capacity of the pile, and the rebound of the O cell is interpreted as skin friction capacity of the pile. So thereby we are taking the advantage of both upward and downward movement of the O cell during the pile load test. So depending upon the test type, so we may get variety of curves. So here a few varieties of the curves has been given depending upon the soil type. So the left two curves, the load versus settlement. Here you can see a beautiful non-linear curve that is loading, and upon unloading, so you can see how the pile foundation is rebounding. And depending upon these things, we can say the settlement is total settlement or net settlement. Total settlement means the settlement during the axial pile load. So net settlement means the total settlement minus rebound. Here you can see ST1 indicates the total settlement, ST2 indicates the total settlement, SE1. So this settlement because of the rebound. So this can also be said as elastic settlement. Total settlement, elastic settlement, then difference of these two will give you the net settlement. Now depending upon the soil type, you may get a perfect bilinear relationship, or after application of certain load it becomes a perfectly vertical curve. So wherever you can see a distinction in the pile behavior or in the graph behavior, that can be interpreted as the ultimate bearing capacity of the pile. So in case of this dotted line, wherever there is a change in the non-linearity or changed from non-linear to linear, so that intersection point can be inferred as the ultimate pile capacity. Or alternatively, if it is the same linear but in a perfect vertical direction, so wherever the change occurs, that point can be interpreted as the ultimate pile load capacity. Now depending upon the curve type, so it can be referred to as well-defined ultimate load or ill-defined ultimate load. You can see in case of the well-defined ultimate load, as you increase the load, the settlement increased, but after certain time the settlement almost became a constant. So therefore if you draw an horizontal line to the constant values of the settlement, and whenever it is touching the vertical axis ordinate, that can be referred to as the Q ultimate. But in case of the ill-defined ultimate, so what you should do is you should draw two tangents, once to the initial portion and next to the final portion. So whenever or wherever these two tangents are intersecting, so that intersection point can be considered as the ultimate pile capacity. So as I told, depending upon the load type, we may get total settlement or elastic settlement or net settlement. See, two examples are taken here. Q1 refers to net settlement is equal to total settlement minus elastic settlement. So at Q2, so net settlement is equal to total settlement minus elastic settlement. Okay, so that means when you do any pile load test, you will get three variety of settlements: total settlement, elastic settlement, and net settlement. So I repeat, whenever you are conducting any pile load test, you will get the total settlement, elastic settlement, and the net settlement. So the code gives some kind of the guidelines. What should be the allowable total settlement and what should be the allowable net settlement. So both are there. So you can get the guidelines on the allowable total settlement and allowable net settlement. So there are some formulas also given. You can use, for example, Davison's method. So Davison has proposed a kind of an empirical equation to determine the settlement. Suppose if your load versus settlement curve is an ill-defined curve. In this case, so he has interpreted like that. You can use this equation. So here all the terms are also defined. SU is total settlement, and dr is a reference pile diameter or width, and d is diameter of the pile in millimeter, and QU is ultimate load, L is length of the pile, AP cross sectional area, EP elastic modulus. Then you can also try to understand what is happening to the soil behavior. So all surrounding the pile, or the other way around of understanding this one is when you do the pile load test, what would be the zone of influence. So one typical interpretation that made by the different people is, suppose if this is the pile, in the lateral direction up to a distance of 0.5 times of the D, the soil is completely disturbed. While after that zone is called as a remolded zone. That zone is called as a remolded zone. And after the remolded zone, the soil in the lateral direction up to another say 1.5 times of the diameter of the pile, 1.5 D, the soil undergoes compression. Up to 0.5 D, it goes the remolded state, and up to 1.5 D, it goes compression. And behind compression, the intact zone means there was no impact of the soil. That means no load is getting transmitted or transferred to the intact zone. That means no load is coming onto this soil. And accordingly, you can also see how the different zones look like. So in a graphical way. Yeah, so that's what all about the pile load test. Now, the pile load test is a field test. Now, there is another way of understanding the pile load capacity. Those are called as a pile driving formulae. Pile driving formula means, now just recall. We have discussed about driven piles and bored piles. So these formulas are essentially useful in case of the driven piles, because these are called as a pile driving formula, or also called as a these empirical formulas. There is specific name is there. There I have shown just to avoid some pile driving formula. Here I have shown to counter check the results from the geotechnical and pile driving formula. So this, what do you mean by the pile driving formula is, just imagine you are driving a pile, that is a driven pile, into the soil. Now during the driving, you have to repeatedly apply the load on top of the pile. So corresponding to each rammer, each impact, so there is a certain insertion of the driving of the pile into the soil. Now, depending upon the amount of the load applied and the number of blows applied, so we can reassess, is there any change in the pile load capacity. So that means, see, when you apply the repeated impacts on the pile, anything can happen. So the pile can get broken, or the only top may get damaged, the bottom portion is remain same, or the cracks may form, or the top surface, the top of the pile may be get fissured out. Anything can happen. Or we also do not know whether the alignment of the pile is perfectly vertical or not. So because of all these uncertainties, so what we try to do is we try to calculate the pile capacity, especially during the driving itself. Those are called as a pile driving formulas. Pile driving formulas. Just imagine, these pile driving formulas are comes even before the pile load test, because if you want to do the any pile load test, the pile has to be inserted first into the ground, then only you can conduct the pile load test. That means, so you have already two variety of pile load capacity. One is the capacity which is calculated by the analytical equations, and the capacity which is calculated by the pile driving formulas. So these two values again further ascertained by the, or by conducting the pile load test. And these are also called as a dynamic formulas. So there are several dynamic formulas are available in the books. You can refer to any of the formula. So one or two I will discuss herein. one of the simple formula is modified engineer's news formula, En called as a engineer's news formula. The equation in case of the dynamic equation is the ultimate pile capacity Qu is EWR into H divided by S plus C into WR plus N square into WP by WR plus WP. So this is the equation. So here WR is weight of the ram. So this is the rammer which you are using, which you are simply lifted up and dropped. So that is the weight of the rammer responsible for the driving of the pile. Then how much you are lifting, that is called as a H. Then penetration of the pile per hammer blow. How much is the rate of penetration? Then C is a constant. So this C could be a function of the soil or function of the pile or function of the anything, doesn't matter. Then E is energy efficiency. So because there is an impact force between the rammer and the pile type. So anyhow, the 100% of the load transfer we cannot able to ensure. So how much the energy efficiency that you are assuming, that is called as a hammer efficiency. Then C is a constant, so which can be taken as 2.54 millimeter if the units of S and H are in millimeter. And WP, that is weight of the pile, and N, coefficient of restitution between the ram and the pile cap. So this restitution is directly proportional to your energy efficiency. Okay, then what values of the E energy efficiency can be taken depending upon the hammer type? Just again recall, we were discussing about pile driving equipment. We discussed about the single acting hammer, double acting hammer, diesel hammer, vibratory hammer, drop hammer, so on and so forth. So depending upon the hammer type, you can take the efficiency, so between up to 70% to 90%. And depending upon the pile type, so we can assume the coefficient of restitution, cast iron hammer and concrete pile 0.4 to 0.5, wood cushion on steel piles 0.3 to 0.4, wooden piles 0.25 to 0.3. And another unknown is how do you calculate the penetration of the pile per hammer blow? So which is 25.4 divided by the N. N means number of hammer blows for 25.4 millimeter penetration. That means you need to calculate the number of blows for every 25.4 millimeter. So which is approximately equal to 1 inch. Approximately equals to 1 inch or slightly lesser than the 2.54 now 1 inch. Yeah. So 1 inch is equal to 2.54 centimeter. So how many number of blows are required for driving 1 inch of the pile into the soil? So that is defined as the penetration of the pile. So that is represented in the form of a capital S. Then this is the formula we did discuss. Then there are other formulas, modified Healy formula. Healy has given two variety of formulas. The ultimate bearing capacity of the pile is alpha into W into H into eta divided by S into C by 2. So again here also, if you look at any of the parameter at the term, all are related to how many number of blows you are applying, how much is the pile penetration, how much is the coefficient of restitution, what is the hammer efficiency, so on and so forth. So W is the weight of the hammer, H is height of the pile, Qu is pile resistance or pile capacity, S is pile penetration, alpha is hammer pile efficiency, eta is efficiency of the blow, and C is some constant. And what value of the alpha shall be taken? That is hammer efficiency, again 0.8, 1 or 80% to 100%. Then there is some constant value C, which is summation of C1, C2, C3. So these account for again temporary compression of the dolly and packing, and temporary compression of the pile and temporary compression of the ground. Just to make you understand, see, when you are driving the pile, there is a rammer and there is a pile top. Suppose if rammer directly contacts with the pile top, okay, if the impact is directly on the concrete, no doubt the top of the pile gets cracked. Okay, that means the direct impact of the rammer on concrete is strictly avoided. So this is a common sense. But to avoid that one, what should be introduced? What kind of material should be introduced between the rammer and the pile top so that there is a transfer of the energy, but at the same time the top of the concrete will not get disturbed. So this is important point. So that's where something called as a dolly. They use dolly and packing. So this dolly and packing is placed on top of the pile top. Okay. So then on top of the dolly, the rammer applies the number of blows. Then other formulas are available. Danish formula, then Ambush formula. So we can use any of these formulas to calculate the pile load capacity during the pile driving. So the last part of this pile foundation is how to calculate the elastic settlement. So the elastic settlement is the summation of the settlement of the pile and the settlement of the pile tip and the settlement of the pile caused by the pile load transmitted along the pile shaft. So the elastic settlement of the pile is summation of SE1 plus SE2 plus SE3. Elastic settlement of the pile itself as well as the soil. So pile plus soil summation both will be accounted for in the calculation of the elastic settlement. So these are the formulas. So how do you calculate the SE1? SE2 is QWP into D by ES into 1 minus mu square by IW. This is nothing but some kind of a strain influence factor method to calculate the SE2. That is settlement of the pile caused by the load at the pile tip. SE2. Alternatively, the SE2 can be calculated by the cone penetration value. So CP, that is an empirical coefficient. Then SE3, that is the settlement of the pile caused by the load carried by the pile shaft, and this is also some kind of settlement is equal to load divided by the elastic modulus, same equation. However, they are related with the strain influence factors. Like for example, here IWS is influence factor, so that gives how much amount of the load gets transmitted to the pile shaft or the pile tip. Okay, and some empirical correlations also available. So they can also be used to determine the pile load. So that means the elastic settlements are related to the cone penetration, CPT or SPT or pressure meter or anything. Now here I have not given the equation for SE1 because this equation is already we have given for the, we did discuss during the settlement, elastic settlement of the pile group. Elastic settlement of the pile group. Just recall the previous class, then you will get the equation for SC1. Okay, so when you talk about the settlement of the piles or pile group or pile foundation, it is the combination of the settlement by the pile itself plus settlement of the pile caused by the load at the pile tip, that is end bearing, then settlement of the pile caused by the load transmitted along the pile shaft, that is skin friction. Okay, so elastic settlement of the pile itself at the pile tip as well as the skin friction or the pile shaft. So I will stop it here. If you want to ask any question, you are most welcome. So this coming Wednesday, we will again go for this